Okay, good afternoon, everyone. Welcome to our Terrascope webinar about the integration with the Copernicus Data Space Ecosystem and openEO. My name is Evelien Steijnen, Communication Coordinator, and today we have three speakers for you, Jurgen Everaerts, Bram Janssen, and Dennis Clarijs. I'll give a short introduction before we give the floor to the experts. Jurgen is project manager of the Terrascope platform. He holds a master in physics, and with more than 30 years of experience in remote sensing, he's a true expert in using EO data and services. Dennis holds a master degree in ICT engineering and is leading the VITO remote sensing services team, which operates several EO-based services, including Terrascope and the Copernicus Data Space Ecosystem. And Bram Janssen, a master in IT, is one of the IT architects behind Terrascope and EOplaza. Bram is project manager at VITO Remote Sensing and involved in several projects, including the Copernicus Data Space Ecosystem and the integration with openEO. Please note that you can ask questions via the Q&A feature in the toolbar. You can upvote questions that were already posted or add new ones. We will answer them in the Q&A session at the end of the webinar. And if you have any technical issues, you can contact us via the chat. Enjoy the webinar, and Jurgen, the floor is yours.
Thank you, Evelyn. Welcome, everybody. Just to get a feeling of our public, we have a poll for you. Let's see. Can you tell us a bit about how experienced you are in working with EO data? So the answers are coming in, and we seem to have a nice spread. A few inexperienced people, and well, the majority today has more than 2 years experience, and some have almost half of them have over 10 years experience. So that is nice to know, so we can make sure that you all get what you're looking for. Next poll that we have is if you are experienced, you're probably working with some of the tools to interact with geospatial data. And would it be possible if you could indicate which kind of tools you're already using? I see some answers coming in. And again, we see that cloud processing isn't exactly new to most of you, but openEO may need some more explanation, and that's what we're going to do. Catalog functions are being used. People integrate data with QGIS and other GIS packages, I guess. This is really interesting to see, and I hope that we can help you in discovering a bit more about some of these applications. Okay, so the first part is about Terrascope. We've been working on Terrascope since 2017, and we must say we've come a long way. Highlights of Terrascope are that we concentrate on providing analysis-ready data. So we take the data that's coming from the satellites and provide it on previously the Sci-Hub and today on the Copernicus Data Space Ecosystem, and we convert them, for instance, in GeoTIFF format so that you can integrate them easily. Terrascope has been known and is still known for unique long-term datasets. Spot vegetation and ProbaV offer a unique view on the vegetation of the Earth over the past 25 years. Obviously, since we've been sponsored by Belspo, we are focusing on Belgium, but you'll see in the coming slides that it's not just Belgium users that are working on Terrascope. And so today we're linked with to CDSE, and we offer a complete data space. And what do I mean with a complete data space? Is that we're not just offering satellite data. We also provide a number of reference data sets. We have information products derived from the satellite data. We have services that you can use to integrate your processing workflows with our data. We have a Terrascope viewer that allows you to discover all of that data and do the first line processing or trend analyses. But we have many ways of interacting with our data via cloud processing. We have the EOplaza that allows you to share your developed process with the user community. And we concentrate on use cases. We want to make sure that the rest of the world knows what value Earth observation can bring. And we see that almost every country in the world has at least one representative working with the Terrascope, and some countries are very prominent, as you can see. Now, what are we going to do in the future? Of course, we will offer continuity so that everybody that is currently working on relying on Terrascope can certainly keep on doing that for the next 5 years to come. There's going to be more data, there's going to be more products and services. We will strengthen our user support, and we will integrate even more closely with CDSE. What is the impact of that? That you can rely on Terrascope to give you a view on the full archive of the Copernicus Data Space Ecosystem without having to switch a platform, for instance. And we want to create more impact. Is Terrascope something for you? I think it is, because we are concentrating on supporting you by helping you onboard your services, by potentially providing you with more credits or resources. We can help you hosting added value data sets, either for yourself on the Terrascope data center or shared with others. We try to be ahead of the curve in user experience. So we are thinking about rebranding and reorganizing our viewer and our website so that we keep on using the best available technology. And very important, there is a certain data offering, there's a certain resources that are available for you. If you have any questions about whether or not you can use Terrascope for your project, never assume it isn't possible. Always make sure that you ask us first before thinking that the Terrascope is not your platform to use. Moving on, we will be discussing openEO in a minute, and please understand that you can start using openEO without any cost. There's a free tier at Terrascope for 1,000 credits every month, which is replenished every first of the next month. On CDSE, the same applies, even more credits that you can use every month. If you need more, you can apply for sponsoring. ESA projects, for instance, give you access to the network of resources. Creodias has a certain offering for specific users, and even Terrascope can help you, especially Belgian users, and especially the Belgian projects can always rely on some more resources or credits, but you need to contact us for that. And then if you need even more, or you're in a commercial situation where you have lots of processing to do, we can provide you with credit packages via EOplaza or via CryoDS. So that being said, it is time for Dennis to tell you more about the Copernicus Data Space Ecosystem. Yes,
thank you, Jurgen. Why do we bring this up? Because this is important, I think, and Vito is part of the consortium that also operates the Copernicus Data Space Ecosystem. So I saw from the first poll that there are people that are not using the data yet. So maybe for that, a recap and what the difference is between Terrascope is that the Copernicus Data Space Ecosystem is, let's say, the source of all the Copernicus Sentinel data for the whole archive, level 0, level 1, level 2 data that is there with all kinds of complementary services. With Terrascope, we are the, let's say, the Belgian extension of this ecosystem, of this data space, where we try to provide complementary services, complementary data sets, and all the things that Jurgen just explained to further help you in your projects. Moving on, if the slides work. Yeah, okay, coming up. So Copernicus Data Space Ecosystem, it contains quite a lot of things. So in the middle, of course, the whole archive of the Sentinel data that is available, complemented with Copernicus contributing missions, some additional Earth observation data sets. So quite a lot of data there. All this data is complemented with some tools and cloud computing capacity. Some of it is in a free tier, some of it is in a commercial tier. There are quite some streamlined data access APIs, and there are also services that support federation in the future. This part is still under development, I would say, the federation part, but we can already present in some slides the plans for openEO. Just to give you an idea on how much data is in there, and this is an extraction from the dashboard from yesterday. It contains quite a lot of data, so 77 petabytes at the moment of Sentinel data. Most of it is from the optical satellite Sentinel-2 because of their multiple processing baselines sitting next to each other. This will change in the future when the whole new collection is processed, then the old collections will disappear in a few months. So a whole lot of data and being used by plenty of people. So today, this Copernicus Data Space Ecosystem, let's say, has a tenfold download of what is there in the ecosystem. So more than 700 petabyte has been downloaded since the start of the operations. Millions of products, to be more precise, 111 million products are published since the start of operations. And at the moment we are at 166 or 67,000 registered users, starting with the system last year, early last year. And that number keeps growing with about 4,000 or 5,000 people per week now. So some highlights that we would like to share here, which is also interesting for people using Terrascope, is I think that what we get asked most is how about the Sentinel-2 collection one, so the new reprocessed data. When will it be ready? So part of it is already there. So there, ESA has initiated a reprocessing already over a year ago, but it's quite some data that needs to be processed, and it's all processed with processing baseline 5.0. And ESA has reprocessed actually the whole archive before the 31st of September 2021. we're finishing up on that, and all this data, so this whole archive should be ingested and available in the Copernicus Data Space Ecosystem by the middle of June. Then there's a second phase starting, where, let's say, the last 2 years, or almost 3 years of data will be brought in line with this reprocessed data. That will take another 6 months before completion. So that way, the whole Sentinel-2 archive will be on the same level, same quality level, while it wasn't there before. The differences between all these processing baselines and what it means to you, I'm not going to explain that today, but I put in a link here. It's on the Senti wiki of the Copernicus website, explaining a little bit more on all the processing baselines. Second thing that is, I think one of the major things that is ongoing for these are the Copernicus contributing missions. So this means these are selected data sets like digital elevation models, very high resolution and high resolution images for eligible users. For now, all these data sets are available through the OData API, so the catalog API that is there. And the visualization for these data sets, so these high resolution data sets, is in progress. So that will be released in the next month. Another major thing is the addition of global mosaic. So that means that every quarter there will be a mosaic made for Sentinel-2, but also all the previous quarters in the past will have a quarterly mosaic generated, and there are already some of them there. So that's interesting for users, so they don't have to start mosaicing themselves. Similar thing will be done by for Sentinel-1, but these are yearly mosaics, and even on a monthly basis, this is being discussed. But that will be there soon as well. Another major release that is on, well, let's say, of the verge of releasing is the on-demand production. So that means that you can process Sentinel-1, 2, and 3 data with specific processing baselines and specific algorithms or eligible algorithms that are out there that will be working through the data space that is there in the system. And yeah, we're actually in the final release or testing phase, I would say, before this functionality is released. And then another one is the stack catalog implementation. There's already one there, but it is being extended, being redefined together with ESA to have a new implementation available, which is much more rich in terms of extensions, in terms of metadata and so on. And these will be released in the month of June. So coming up in the next few weeks. To give an idea on the Copernicus contributing missions, you see here which data sets and which type of data sets are being onboarded at the moment and will be there soon to be visualized. So this is a nice addition as well for users to explore these high resolution, medium resolution, and very high resolution data sets. All the other things on the roadmap are here. So there was a new update published today, actually, on all the new features that are coming up in the Copernicus Data Space Ecosystem. Not going to go over all of them today, but you see this is a system quite in motion, preparing for extending the ecosystem part of the Copernicus data space, but enriching now with new features, new data sets, and so on for people to further build upon, and also to be complementary with the Terrascope offering. One thing that is noteworthy is the openEO Federation that is to be released in June. And what is the openEO Federation? That's one of the approaches to realize an ecosystem. So ecosystem meaning that the European Commission, which is funding this activity, really wants to have a place, a space for companies to further build upon with all the functionalities that are there. And openEO is one of them. And openEO builds further upon the open source component there. At least the Federation builds on the openEO component and is depending on the stack catalog as well. And it federates data access and processing capacity. So what we see, or we see in Europe, next to this Copernicus data space, there are plenty more platforms that have additional data sets, like we have for Terrascope, but also at EUMETSAT, other collaborative ground segments. So in Germany, in France, for example, they have other data sets which are interesting, and they want to make sure that these data sets can be used as well through this federation. So that means that through this, what we call an aggregator concept, these data sets can be queried, can be processed, can be extracted, can be combined, and so on. And this is what we try to achieve using this aggregator concept in the Copernicus Data Space Ecosystem. So today there are already many processing capacities that are there, and openEO backends that can be exposed. And for releasing this, Terrascope will be the first one that will be entering the federation here. And we are actually ready with the deployment of that. And this is where we are at today. So we have an endpoint in the data space combining the data sets of Copernicus Data Space Ecosystem and Terrascope. And in the openEO web editor component, it looks like this in the screenshot on the left side, where you can see ProbaV data sets, but also all the Sentinel data sets that are available. So you can really start building upon these data sets, while in the backend processing will happen on different backends in Europe. And all these backends have different functionalities, but they are nicely integrated then into this aggregator concept. Now, this is an update for the Copernicus Data Space Ecosystem, but there's much more on openEO next to this federation, and I will give the floor to Bram to explain what is happening on that side.
All right, thank you, Dennis, for already introducing openEO. Allow me to take actually one step back and explain a little bit more on what openEO is, what it can do, and also explain a little bit on what the roadmap is, or what we're planning for new features in the upcoming year. So I noticed in the poll that not a lot of the participants today know about openEO or have used openEO. So just a short recap on what openEO is. In essence, it's an API. So it is an API where you can construct a processing workflow by defining the different steps that you want to execute. So the goal of openEO is to actually simplify accessing Earth observation data sets and processing them on a very large scale. The goal is that it's processed as efficient as possible, and again, supporting upscaling of your processes so that you can process data sets on a continental scale, for example. It is done through an API, so it's kind of a standardized way, which means that if there is an organization or a platform such as Terrascope or the Copernicus Data Space Ecosystem that implements this API, means that you can actually move your processing workflow from one system to another. So in theory, if you build something that is working on Terrascope, you should be able to also execute the same workflow on the CDSE environment, for example. One of the big advantages as well is that you just define the different steps that need to be executed, and it's actually up on the processing platform to do all the magic and all the calculation for you. So you are actually not aware of the different technologies and libraries that are used behind this API. You don't need to care. It's actually the responsibility of those backend implementators to make sure that the processing runs as smooth and as efficient as possible. Additionally, there are openEO API itself and the services it provides provide foundations for the FAIR principles and also open science, ensuring that what you've built is transparent, can be reproduced on different systems, and can also be shared amongst other parties. So what if you want to learn a little bit more about openEO? For starters, we would recommend starting with one of the online courses that has recently been launched, which is called Cubes and Clouds. So this online course gives you a short introduction on the main concepts that are also part of openEO, which are data cubes, cloud platforms, and open science. So if you would follow this course, you already get the grasp of the base concepts that are very important when you start using openEO. If you are already using openEO and you know the concepts already, another interesting resource is our openEO community examples. So we have a GitHub repository where we have more than 18 different Python examples, so notebooks where we explain code line by line what we do within openEO and how we can implement a certain use case. We have examples on how you can do partial delineation using Sentinel-2 or detect heat waves, for example. But we also have notebooks that help you really get started. Let's say that you start from scratch. This notebook will help you explain the different concepts of openEO, the different services it provides, and so forth, but also focus on certain techniques, such as creating composites. There's quite a lot of examples that could help you in evolving your skill set within openEO, or just learn what it has to offer. We also have a couple of interesting use cases that we can share with you to showcase what openEO actually can do. For example, in this case, for the EO Africa National Incubator, a drought monitoring product was integrated or calculated using openEO. So it's in its simplified version, we took 3 different kinds of input data, combined them in a decision tree, all implemented within openEO, and we generated a combined drought index for South Africa. So this is something that we have built together with GMV, where the whole process of the data collection, the decision tree, and then the generation of the drought index was implemented in openEO. Another example provided by DHI is water detection. By combining Sentinel-1 and Sentinel-2, again, in a decision tree implemented in openEO, we can extract water bodies from satellite images, which is very useful to follow up and see how these water bodies evolve throughout time. We also have more under the hood or more complex use cases as well. For example, when you work with Sentinel-2 data, with optical data in general, you usually have the challenge of working with clouds. And we also have services or use cases that focus on optimizing the temporal consistency of your time series by, for example, confusing Sentinel-1 and Sentinel-2 data to ensure to gap fill all of the clouds, for example. QCS is an example of this, where we integrated the Whittaker service into openEO, but also GAN-based models, for example, MOGPR, where data is fused and gap filling is being applied. We also have use cases that are more focused on AI and machine learning, such as the wind turbine detection created by DHI, where they actually implemented neural networks within openEO. So the training and the inference of the windmill detection is completely implemented within openEO in this case. But also other useful tools for machine learning are available. One of the key activities is the large-scale dataset sampling, which is facilitated by using openEO, and really the fact that you can do a lot of processing in parallel is really something that's really where openEO really starts supporting these kinds of activities. Another example where we showcase what it can do really on a large scale is, for example, the crop type mapping, where based on time series, we predicted what kind of crop is being grown at each single location, and that for the whole, we did this for the whole of Europe and 5 years in a row, for example. So we can also upscale everything that we do quite easily with openEO. One of the last features that was added is the creation of monthly composites. So before we released this feature, you had to calculate these composites yourself if you want to use them. Right now, this is baked in as a feature in openEO through the best available pixel algorithm. Again, this is available as a use case and an example on the GitHub repositories. And one of the last feature highlights of openEO is Sentinel-3 processing. That was added quite recently because in general, it's very hard to read and access Sentinel-3 datasets. And therefore, openEO has focused on supporting Sentinel-3 datasets. There are 2 right now available. And one of the use cases that we implemented with these datasets is the heat wave detection. Again, it's available as a community example. So if you want to know how it works, how you can do this stuff in openEO, you can access or get more information through these communities examples. So what are our upcoming features for 2024 and 2025? For this year, we will be mainly focusing on extending the way that you can run openEO. For example, by using Docker containers or a Dockerized solution, or running it locally on your computer, which means if you have datasets on your local environment, then you can run openEO on that environment and start processing the data in the same manner as you would do on a cloud-based environment. One of the key features is also the rollout of the CDSE Federation, which was also highlighted by Dennis already. So where we want to first focus on the cross backend processing, which means that if you want to build a processing workflow where you want to get some data from CDSE and combine it with data from Terrascope, for example, that will be one of the first use cases that we want to support, that you can do this within the same workflow, for example. Another focus is on the machine learning parts and features that are provided for within openEO. So first of all, we'll be focusing on the training and inference for CatBoost, because this is a very important feature for the World Serial project. And then we will also work on general improvements and support towards users. For example, we will be focusing more on supporting projects on upscaling their service. So going from a small parcel field algorithms to continental scale, for example. Also supporting more tools to encapsulate what you have been building into on-demand services so that they are easily shared amongst a larger community. So this is where we focus on the service and UDP, the user-defined processor tooling. So encapsulating everything as on-demand services. And also extending the way that you can retrieve results from openEO. Right now, you can download the results to your local environment, but we also want to support alternatives such as exporting it to object storage or directly ingesting it into a Stack catalog. For 2025, we'll be aiming at adding SAR processing to the openEO capabilities. However, if you're working with openEO and you want to have a new feature within openEO, or you have a use case and you want to have additional support, what we recommend you to do is to reach out on the CDSE forum. So this is a place where a lot of openEO users are interacting with each other, and also the openEO team is actively monitoring the questions that are being posted right there. Or everything within openEO, all the different components are open sourced and are available on GitHub, so you can also interact through one of the GitHub pages as well. So this is a short update on openEO, which brings me to the last section of today, which is on the EOplaza, and it's kind of a continuation on where we left off with openEO, where you built a nice workflow in openEO, and now you want to, of course, share this this service. You want to create an on-demand service and share this with a larger community. And this is where the EOplaza comes into place. So the EOplaza is actually a kind of a marketplace where you can onboard your service and make it visible to a larger community. It allows you to really come into contact with users. You can get more information on how your service is being used within the community. And especially, you can just increase the visibility. So instead of having it only available for you, you can give it to a lot of people so they can reuse it on their terms and integrate into their workflows. Thanks to the EOplaza, there's also a possibility to generate additional revenue. If you want to generate an income stream based on the service that you have developed, EOplaza can provide you with the tools to do so. What is the actual EOplaza? What does it actually contain? So the main interface is the user portal. So you can access the one from Terrascope and the one from the Copernicus Data Space Ecosystem through the links below. But in general, the user portal gives you a catalog of the service where you can browse, you can get insights on how people have been using your service, and you can also manage your credits, which were mentioned by Jurgen in one of the previous slides. You can buy additional credits, see how the credits have been used, and so on. The user portal is directly in contact with what we call so-called orchestrators. These are actually processing platforms, and in the specific case of EOplaza or Copernicus Data Space Ecosystem, this is openEO. So the user portal is directly integrated with openEO, which means that you can execute services directly within the openEO web editor, for example. When you start executing these services, they end up on one of the platforms, the actual processing platforms, which is in this case the Terrascope environment or the Copernicus Data Space Ecosystem, or the federation as presented by Dennis. So this gives you an idea of the whole structure of the EOplaza. So why should you use the EOplaza? First of all, the goal is to provide a range of qualitative service. So we want to onboard services that ensure that you don't need to reinvent the wheel again, that you can easily reuse within your own workflows. We are also constantly working on the different platforms that are below it. So in this case, Terrascope or the CDSE platform, we are constantly improving it, making sure that the processing happens as efficient as possible. And this is done by a team of experienced experts, people that are both experts on scientific level, but also on a technical level. So whether you need support with use cases in a specific context around a certain team, or you need to have support on an IT level, you have people with a broad range of skill sets that can support. Another important aspect is that we also apply service levels to the different services on the EOplaza so that you can get an idea on what you can expect. We want to, first of all, make the onboarding process as easy as possible so you can self-onboard your algorithms, but we also want to make sure that the right expectations are set. Is this a prototype? So can it fail at some point? Or is this a really operational service with validated results, for example? And lastly, there are multiple kinds of interfaces that are available through the EOplaza that allow you to both execute and create services, ranging from direct integration with the openEO web editor, giving you a point-and-click interface to execute services, to Python, R, JavaScript libraries that you can use to start integrating services into already existing workflows. That brings me to my last slide. So how can you actually onboard the service onto the EOplaza? First of all, you should implement your algorithm or your service in openEO, and you can choose the Terrascope environment, the CDSE environment, or the federation, where you have more data sets and more processing capacity by combining the two platforms. You should then share your algorithm as a user-defined process. There are guidelines in the openEO documentation on how to do this. And then you can use this information to easily create your entry on the EOplaza and publish your service there, making sure that it's available to the larger community. I think then the last couple of slides are some questions that we want to ask you, for which I give the word back to Dennis.
Yes, thanks, Bram. So indeed, we have touched upon quite some topics already today. But for our inspiration, we would like to have a look at you and see in the future how we can assist you with information. So we have several options in the poll that you can answer to give us a little bit of inspiration there on how we can improve our services, improve our information towards you. So I see there are quite some answers coming in with some general interest in openEO and the use of the web editor, for example. So that's good. Keep it open for just a few more seconds. So yeah, clearly there's a need for indeed the notebooks, virtual machines, and use of openEO in the future, and the integration of datasets into QGIS. So all very interesting topics, I think. I don't see anything specifically in the chat. So we will take this with us and start planning ahead already. Then we can go to the next page and we can end this poll where we have two more questions for you. So in terms of use cases, we with Terrascope, we are in service of the user or the community, and we would like to know in terms of thematics which would interest you the most. So there are two questions. So first one is on the thematics. And second one is how can we support you not only with future webinars and so on, but really hands-on. How can we help you with your work, with your projects? Can we promote your services, your use cases with webinars, with news, and so on? Can we support you with onboarding the service into EOplaza, so what Bram just explained? Or can we support you with other technical support, engineering support? Can we sponsor you with credits, for example? That would be interesting for you as well, and we'd like to know if we can contact you for that. So see many answers coming in. So I also see there's quite some interest in environment, land cover, but also water. I think that's interesting because we have some water-related use cases as well for Terrascope, which we can support. And the second question is the promotion of services, onboarding onto EOplaza. So really interesting to see that. Okay, now we continue with the interaction with the last parts being questions towards from you. We will stop with our questions. And I've seen that there are already some in the Q&A. So Jurgen, do you want to moderate that part?
Yes, thank you everybody for attending and providing us with many questions. There's one related to in situ data. How will we connect to in situ data, for instance, coming from the Copernicus services?
I can try to answer that. For now, there are not too many plans in Terrascope for in situ data. We are aware that there is a growing need for getting access to in situ data. We are aware on European level there's something, for example, called GBOF. So it's the ground-based observations for validation. So there are data sets available there. There's a viewer for that, but we do not have a direct link to Terrascope for this. and nothing planned at the moment. So for now, that's the best answer I can give on this question.
Coming up and related to that, there's a high value dataset regulation upcoming in June under the Open Data Directive. And again, what are our expectations with regard to increasing availability through APIs for in situ data? But I think Dennis has already explained that. Next one is, how do you ensure the pre-processing and geocoding of Sentinel-1, 2, and contributing missions for analysis-ready data? Because we're on the one hand relying on the pre-processing that is done at ESA. We rely on level 1, level 2 data, which is already geocoded. For the contributing missions, I'm not too sure, but I guess they are as well geocoded as the others. And then converting that into analysis-ready data is something that we do on Terrascope. But actually, openEO makes that pretty transparent as well. So if data is available somewhere, openEO takes care of all of the necessary actions to make it available in your processing. Is Terrascope, the SAR data, is it possible to process SAR data sets in openEO on Terrascope today? I don't think so. It is in the plans for next year. Obviously, we do offer SAR results. So the ground level detection detected for the data sets over Belgium. In the CDSE, it's for the whole Earth. The SLC data is available in the catalog, but it is there is no way today to process that via openEO.
Well, there is actually, Jurgen, I need to correct you there. There are possibilities to radiometric terrain correction and processing backscatter. The possibilities that are being looked into for next year is more towards interferometry in SAR processing. Right. So there are processes specifically there for Sentinel-1 processing as well.
Yeah. Okay, there's the next one about crop classification. Bram, maybe you should have to answer that. Do you combine Sentinel-1 and 2 data for crop classification, and do you only use EO data for that?
I can answer the first part. For Sentinel-1 and Sentinel-2, we do. For the how much the time range is, I have to double check. I'm not sure whether we only use the growing season or beyond. I can imagine that it will be beyond the growing season, because these growing seasons are depending on the different crop types. But I can double check this.
Okay, a question related how to compare openEO to Google Earth Engine. So one of our attendees is using Google Earth Engine. It seems like openEO is similar to GE in early stage. The catalog is smaller than Google Earth Engine, and can you please specify why you need to consider openEO instead of GEE?
Very good question. I think if you're working on GE, you're a little bit, let's say you have a vendor lock-in into the Google services. You rely on that. There's a lot of possibilities, of course. It's a very, very interesting system. openEO is, on the other hand, a open source system, so everybody can contribute to that. It's also being proposed now as being an official OGC community standard. So let's say that many people can contribute to that, and the ecosystem only grows. We see month after month the usage growing. We're not at the level of Google Earth Engine yet, but at least yeah, the numbers look like a hockey stick, I would say. That's looking very good. Also, when I look at the question, there's a comparison with the data catalog. Indeed, I think the catalog that is now available on CDSE and Terrascope is indeed a lot smaller than on what is available on Google Earth Engine. But with this federation concept, we will that is actually opening the door towards adding a lot more federated data sets in Europe. If you look at all the national data sets that are available, new missions coming up, and we're really at the source of the data. So Google Earth Engine also downloads the products from the Copernicus Data Space Ecosystem. It's a large customer, of course, but they need to get it at the source. So I think the timeliness of the data in the Copernicus Data Space Ecosystem and also Terrascope is better than in the Google Earth Engine. So yeah, there's a lot of things to say on that, but I think we can leave it to for today.
Okay, a question, a very technical one. Can you use this hub to access non-Sentinel but cloud-hosted geospatial datasets and leverage the compute on the hub? I would expect Bram to be able to provide an answer to that.
I'm just trying to understand what is meant with the hub.
Well, as I see it, let's assume that the data is on Amazon somewhere, and you want to combine that data together with the CDSE offering via openEO and compute it on CDSE.
Yeah, then it is possible, but it has its limitations, and it has some requirements for the data to be hosted somewhere else in order to make sure that it can be combined. But there are these guidelines are available in the documentation on how you can combine the two. This is also something that the openEO team is actually working on to improve the compatibility with including data that's hosted externally. Yeah. But it's already supported, but in a limited case.
Okay, it makes sense that openEO can't control the data that is on the other side, and so exactly. There has to be some rules. Okay, coming to the final question again for Bram. How much user traffic is there on openEOplaza, and how does the revenue generation work?
Yeah, so on the traffic itself, it's quite limited now. So we have a couple of hundreds of users each month that visit our EOplaza. But this, like Dennis also mentioned, this is like a growing ecosystem. So we are at the start of it, and we see that more and more projects and organizations are creating their on-demand services. Also, projects require them to create on-demand services and publish them somewhere on either CDSE or on EOplaza. So the number of services is something that's everly growing. Right now, it's not that big of an offering, so we don't have that many users yet, but we see it again growing steadily each single month. Regarding the revenue generation, we apply quite a simple concept where if you execute the service on openEO, it requires a certain amount of CPU, of memory, of storage to execute the service, which is a baseline of the cost that we always deduct from the credits from the user. And through what we call added value costs, you can actually define a margin that will be put on top of this processing cost, and then we can set up agreements that this added margin will be refunded back towards the organization.
All right. I think we've gone through all of the questions, and we're close to 5 o'clock, so it's time to wrap up. Please, all of you, come again. There's another very interesting webinar coming about CropStar, which is actually a technology of combining Sentinel-1 and 2 to overcome cloud cover limitations. So that is of interest to almost everyone. I want to, I see there's one final question. How is NRT, how NRT is the data in openEO in terms of availability of Sentinel images? For instance, I have software of early warning system for water quality, which I use Motus as a main software. Why should I change to openEO? I think the data availability is as fast as the data is available from the satellites. So I don't think CDSE that you can get the data any sooner than via a CDSE.
Yeah, the timeliness on the CDSE, there's a dashboard that tells a little bit about the timeliness of the products, but I think there are specific KPIs on that, and that the majority of the data is whenever it's processed at the processing center, that it needs to be ingested within, I think, 15 or 20 minutes on the CDSE. So it's quite fast. I'm not sure what Motus is as software. I'm not familiar with that. Also, not sure if openEO will be the right choice for doing that. Huh? If you want to go for real time, openEO is really scalable. It can be from let's say very small scale processing up to large scale processing. But if you really want to have fast access to the data, maybe it's a better deployment to do it directly on the cloud infrastructure that is there. As openEO is more of an advantage to do things asynchronously. I would invite you to look at the pros and cons of all the APIs and infrastructure that is available for your specific application.
All right, and that needs to be the conclusion of our webinar. I saw that there was a number of people that were interested in getting more information on onboarding and promoting their services. I'm not sure if we have the information of who voted for what, but anyway, if you are interested in any support that we can offer, please contact us. There's many ways. Email is probably the easiest one, and we'll get in touch with you as soon as we can. Thank you, Bram, Dennis, for the presentation. Thank you, Evelyn, for setting this all up and coordinating it. And thank you all for attending. And please come again.
Thank you. Bye-bye.